All right, 114, which is the last section in Unit 1. We have finally reached that point. Okay, it's called Function, Model, Construction, and Application. Basically, you are going to be given data, and you are going to learn how to plot it on a stat plot, like a scatter plot on your calculator. And then from there, determine what type of model it is, whether it's linear, quadratic, or cubic for now. And then I'm going to teach you how to use your calculators to actually come up with the equation for that model. Okay, so most of today is calculator based, but just to start with, you're going to have to learn how to identify these types of models from a graph. So when you're looking at scatter plots or stat plots, your calculator calls them, you're looking for an overall shape. This is obviously not a perfect line, okay? But this would be a linear model because basically, if I were to draw a line, it's the best model for it, okay? So your model, if it is always increasing or always decreasing in a somewhat shape of a line, that's going to be linear. If you looked at something that, when you see your data going up and coming back down again in that parabola-esque shape, so something like this is going to be quadratic. It can go in reverse too, like if you see your data start, come down, and go back up again, obviously that would still also be quadratic. So if it takes on that general shape. Now realize you may not have that full curve. If my data started like here, like let's say this was shifted over, I might only have some part of it, but you will see it take a curve. So it will go up and come back down again in some way, or again the other way around. You may not see that full U or N, okay? And then the last one is cubic. And the cubic, because we're not talking about a perfect cube like x to the third, we're talking about something that has other variations. It's going to take on some sort of a curve where it comes up, comes back down again, and then goes up again. So you'll see it actually come up, come down, and come back up again. That would be cubic. The reverse of that is it could come down, come up, and come back down again like that. That would also be cubic. And again, you'll have some portion of that. You would have to have enough to know it's going up and at least one point to know it's coming back down again to know it's not quadratic. And same thing here. Like if it starts here and it only goes down and back up again, that wouldn't be enough information. You would assume that that's quadratic. You have to have at least one point that lowers here. Does that make sense? Yes? Okay.
What if it like gives you like a graph or like the points you start on like at the middle?
The points you are given will make this shape. Okay. Yeah. So then the first thing you're going to do is plot that stuff either by hand on a graph, or you would plot it, and I'll show you how to do it in your calculator, and then you'll determine from there which of these is appropriate. So this example is like Jeff Bezos' net worth, which is insane. It says plot the data on the coordinate plane and determine the best model for the data. Now notice that it's years here on the left-hand side. It's from the year 1994, and then it goes to 1998. But on the bottom, it says year since. So you want to pay attention. When you're plotting data that has a year, it is year since, whatever that first one is. So you're not counting it 94, 95, 96. You're saying 94 is year 0. So then 95, 96, 97, 98 is year 4. And then 2002 is year 8. And you're going to go on and like that, okay? Then 6 more, that'd be 14. And then 7 more, that's 21. 3 more, that's 24. And 2 more, that's 26. So when you go to plot this on your x-axis, again, you're not plotting the actual year. You're plotting year since the beginning. And then on the left-hand side, it says your net worth in billions, which is what this is, okay? He started out like the rest of us, poor, right? He started out 0. And then in 98, which would have been year 4, he was at $12 billion. So a little bit up here. And then in 2002, it went down a little bit to $10 billion. So that's year 8. And then at year 14, he's down to $2 billion. He lost all his money. Well, poor guy, only at $2 billion. And then at year 21, he's at $50 billion. So way back up again. That was a good year. And then year 24, $100 billion. And then at year 26, $136 billion. So when you follow that path, this is my overall shape. What kind of shape does that look like it is? It's cubic. So when it says determine the best model for the data, it would be cubic. And then it says use the graphing utility to enter the data and confirm your model choice. So this is what we're gonna do. Try to do this as not shaky hand as possible. All right, if your partner or person next to you is not paying attention, give them a nice little smack, because I'm pretty sure this is not something any of you have done, so you want to pay attention, okay? Like a friendly little tap. Okay, so in order to enter the stat plot stuff, you're going to this menu that says stat, okay? We're going to do a lot of stuff here. We're going to hit stat, and on the first screen, we go to edit. When I want to enter the information, I go to edit, so I'm going to edit. I'm going to clear mine out. So if you go to the L number at the top and just say clear, it clears it out. Clear and enter, clears it out. You're going to want to know that for later because obviously right now you shouldn't have any information, but eventually we're going to put stuff in and then clear it out. Then my L1 is all my X or my input. So it's 0, 4, 8, 14, 21, 24, 26. I entered in all the X or all the input. 0, 4, 8, 14, 21, 24, 26. Then in L2, you're going to enter in all the Y stuff. So 0, 12, 10, 2, 50, 100, 136. 0, 12, 10, 2, 50, 100, and 136. Then in order to see this on a graph, we have to turn our stat plot on. So above the Y equals, it says stat plot. We're going to go second, Y equals to get to that menu. And you notice the very top one, it says plot 1, and yours will say ... off. You want to turn it on. So if you just hit enter on it and switch it from off to on, literally hit enter on, and then hit graph. With me so far?
Nothing happened.
You should have one little point there and like the top part of that other point. Why don't I have all the points? I got to zoom out or adjust my window. So the best thing to do is adjust your window specific to the data that you have so you don't have to keep zooming out randomly. The further you zoom out, you're going to lose, like you're going to have more space over here too. I don't need that space. I only need the stuff that's fitting my data. So I go to my window. And I'm going to adjust it based on the data of this specific question. So my lowest Y or X is 0. You could literally start at 0. You could start at -1 if you want to see the axis. But you could also start at 0. Did I do -1? -1. There we go. Now the X max, it goes all the way up to 26. I want to at least see 26. So I'm going to go to 30. You could go to 27, whatever you want there. I'm going to leave my scale alone for now. I'm going to go to Y min. What's the lowest Y? 0. So again, I'm going to go to -1 just so I see the axis, but you could start it at 0. And my Y max? 136. So I'm going to go 140 just so I get that full point. And then I go back to graph. So fun, right? I know I'm a nerd, but this stuff is cool. Yeah. Yeah. To get to the window thing? Window. It's the third button. No, second button. For what? To get to the stat stuff? On. then stat. Yeah.
Okay, I do not know what I did. Like, I did exactly what you told me to do. But...
You have another graph in there, that's all. You have another graph.
Oh,
That's from this morning.
Do I change this?
So your window, you didn't give it all the way. You gotta go. We went Y max of 140 because the biggest Y was 136.
Oh.
What do I change?
So we made the Y min -1 all the way up there.
Oh, why do I change that?
Because you want to go just a little bit smaller than your smallest x, and your smallest x was 0.
Okay, so
-1. And then our biggest x was 26, so we went to 30. So
Oh,
hit
for
enter.
this?
Yep, go 30. You can just hit 30. It'll override it.
Oh,
Oh, not once you start typing.
Oh, okay.
Sorry. Yeah.
It's okay.
Okay. Now go to Y min.
uh-huh.
And we made it -1 too, so that we can see that one. And we made the Y max 140.
Because it's 136.
Correct.
Okay. And then graph.
And then graph. There you go.
Okay, perfect. Thank you.
Yeah, what do I do after on stat?
Enter in all your data.
Into what? Sort.
Stat, edit.
Okay. And then just like L1.
Enter it in. Yep, enter it in. So do that because you got to catch up because we're going to do something else
I
afterwards.
did that, but there's like a line.
You have something in your graph. Clear that out. So listen, if you see something other than your stat plot in there, it's because you have another equation sitting in your y equals. Clear it out. So go to your y equals and clear it out.
Okay, after this,
Yep.
then what do you press second y equals?
No. To turn the stat plot on, you mean? Yes. Second. And then hit enter. And we're going to turn that on. Hit enter. Now go back to graph.
There you go.
Like literally you can hit graph or you can hit second quick, then it goes back and then you go back to graph. Now you have to adjust your window. So go window and we made it -1. This thing. Delete. We don't want that. We went to 30. And then the Y min we made -1. And we went to 140.
For this one?
Yep. If you just start typing 140, there you go. Hit enter. Now go back to your graph. There you go.
Okay, perfect.
All right, we ready for part 2? Yes? Anybody not looking at a stat plot that looks like ours?
What did I do? What is hit all 3?
Oh, you just like deleted out the actual line. It actually shouldn't matter. We would make it line 1, and this would you would want to change it to line 3, and so I'm just gonna clear it.
That's fine.
Second plus 7, 1, 2 clears it all the way out.
Okay.
Now you gotta type it back in. I mean, stop. Edit. Oh, mine clears back out when I do that. I don't know what you did, to be honest.
Yeah,
If you if you go to the top and instead of hitting clear, you hit delete, it will delete that column. But I've done that, and then when you go to second plus 7, 1, 2, it clears, it brings it back. So I don't know.
Bipolar.
Yeah.
Hi, Miss Criswell.
Yeah.
So I was in the bathroom while you guys were teaching this. So so Daniela went through this with me. This is the stuff she told me to put.
Yeah.
When I click graph, it's zoomed out.
You have to turn your stat plot on. So second stat plot, that has to be turned on.
Oh, so just
I'm not giving you I give you a look because she said I went to the bathroom when you were teaching, and that's my pet peeve. Go. Now you can adjust your window. Yeah.
Thank you.
So the window, you want to adjust your window. I'm gonna pick up where we left off because you're not done, people. You're not done. So remember we said, guys, part 1 was actually finding out the type. So the goal is to do that from the calculator, not having the hand plotted anymore. You're going to type in all your information because I'm not going to give you a graph. You don't need it. You're going to type in all that information. You're going to plot it like we just did. You're going to look at the graph that's given, and you're going to say from here, that looks cubic. Question 1, circle cubic. It's going to say which one is it, okay? Then it's going to say, use your graphing utility to find the regression model that best matches your data, okay? And this is how we do that. So I'm going to hit record, start recording. Okay, this again, important. If somebody's not paying attention, lightly tap them. Don't smack. I mean, it's okay, but don't. You're going to go back to the stat menu. And you're going to arrow over to calc for calculate. And you're going to choose the regression that matches which one you just selected. So notice that there's a linear regression. You're going to need this for later. A quadratic regression, a cubic regression. On the homework, there's a quartic one. That's where it is, okay? But we picked cubic, so we're going to go down to cubic reg, which stands for cubic regression. And I get this menu. Yeah.
How'd you get to the stat?
Stat is the button stat, and then arrow over to calc on the stat menu. And then arrow one over to calc, and then go down and pick cubic regression. Now look at what's here. So it says L1 and L2. Is that the list we want it to use? Yes, that's what we called, like if you go back to our stat, we used L1 and L2. That's where our information lives. If there was more than one, so like Camilla, if yours was stuck on 3 and 5, you would pick 3 and 5 there. But we want it to be 1 and 2 because that's what we used, okay? And then we're going to go down and don't do this yet. We're going to hit calculate, and it's going to give me the value for your coefficients of your A, your B, your C, your D, whatever it fills. But we want to see this graphed after that, because you're going to graph it on top of your stat and see if it gives you the curve that you want. And to do that, you go next to where it says store reg EQ. So where do you want to store the equation that we're about to go to? And I want it to go to Y1. So remember, there was 2 ways to get to Y1. One is alpha trace Y1. And the other is vars, V-A-R-S, or vars, arrow over, function, and hit enter on Y1. So what I just told it to do was take the equation that I'm creating and put it in to the Y1 on my graphing menu. And then I scroll down to calculate and I hit enter. And it gives me A, B, C, and D. So the A is going to go in front of the x cubed. The B is going to go in front of the x squared. The C is going to go in front of the x. And the D is going to go by itself. Yeah?
Plug in those decimals?
I'm literally going to write that out. Well, 3 decimals each, but yes. Before I write this out, because this is hard to hold and write at the same time. Before I write this out, we're going to see what it looks like. So if I go graph, it should match up. It doesn't have to be perfect. Sometimes it's not going to be perfect, but it should be your overall shape. This is when your graphing calculator is way smarter than you are. Okay? Does that make sense? So again, it doesn't have to be perfect. It can go off a little bit. Like if you see it goes a little bit under the middle 2 points, it goes a little bit over the 4th point. That's okay. As long as the overall shape is there. Yep. You go, so I'm going to go back to that menu. Stat. Cubic. I put Y1 here. And then I go to calculate. And I'm actually going to screenshot this time. Because that is what I need to write as my equation. So where it says enter the data, confirm your model choice. We did that. Find the regression equation, and this would be y equals A, which is 0.0278, so 0.28 x to the third. B is negative, so minus 0.6996. The 6 bumps the 9 bumps the 9, and this becomes 700 x squared. The C is positive, so plus 4.708 x to the first, and then plus 1.0915, so 092. I know. It's in your, because we put it there.
Yeah.
Yeah.
Yeah, but the only thing is I have to like arrow it a bunch.
Oh, you mean to read it? Yeah. But I would do it before I even hit. I would do it before I even hit to see it. I would write it out. But yeah. Uh-huh.
So I have to put the extra zeros after the stat.
I actually am gonna say let's get in the habit of it. I don't know that I would have marked it wrong, but I did hear that AP Calc does. So we're gonna say keep the 3 digits. Yeah. Yes. We're gonna do it again though. And the last part of this question says, find the average rate of change from 2015 to 2023. So I need to find F of 2023. And this is not really 2023. I have to figure out how many years after 1994 that is. Minus F of 2015 over 2023 minus 2015. But again, not using 2023 and 2015 because 2015 was year 21, right? We're not using the actual year. We're using the years since 94. So then 2023 would be 29. So I'm going to do F of 29 minus F of 21 over 29 minus 21. Now I already stored that in the calculator, so I could literally use the fraction. So alpha fraction F of, or Y1, so I want to go to alpha calc, Y1, I'll take a picture of what it looks like when I'm done, minus alpha trace Y1 of 21 over 29 minus 21. And it looks like this.
Miss Chris was right.
Wait a minute.
So the rate of change from 2015 to 2023 is 22.322, and it's billions of dollars per year. Just throw one of those our way, huh? Yeah, you're putting it in terms of a rate, so you want to be specific. If it was a real world thing and it gives you the units, you need to make sure you include it. We're doing the process again. So where do we start with? How do I enter in my data? Stat. Okay. It should already be turned on. You can check it, but when you go to stat plot, it should already be turned on. That you don't have to keep turning on and off. But also, what's in Y1? You have to clear it out. Does that make sense? We put it in Y1 from before. We don't want that there anymore. We want our new stat. So I'm going to stat. I'm going to edit. And in these columns, you should see your data still, right? If you go up and highlight L1, if I highlight L1 and I hit clear enter, it's gonna clear all of L1. If I go up to L2 and I hit clear enter, it's gonna clear all of L2. Yep. So when I do second plus 712, it comes back. If you want to try that, it didn't for Camilla. We had to like reset something else. But hopefully mine comes back. Just do, when in doubt, restart. Okay, good. All right, now I'm going to enter 1, 2, 3, 4, 5, 6. And then I'm going to go over to L2, 10, 6, 5, 5.5, 6, 11. What do you notice about your data? What about your Y's? It's going down and it's coming back up again, right? So I'm going to go to graph. And we have our window so teeny tiny. You can either reset your window by going to window and doing -10, 10, -10, 10, and seeing if that's good. Or you can, again, adjust it to your data. So if I wanted, God bless you. If I want to adjust this, I want my Y min literally could be 0 because it goes from 1 to 6. My Y max can stay 10. That was my X, sorry. My Y min, the lowest min I have is 5. So I could leave it at 0. I could go up to 4, something just to make sure I catch it all. And I'm going to go all the way up to 12 so I see the Y max. And then again, graph it. And now I can see that quadratic shape. So I'm going to say quadratic is the best way. I just left it at 10, as long as it's bigger than the biggest one there. Now I'm going to go second. Not second. Sure, as long as you see the full curve. It's just further out. I'm going to go second stat plot, make sure it's turned on, and it is, right? That's what I would have done if it didn't show up. Then I'm going to go to stat. I'm going to go to calc. This time I'm going to quad reg, because it's a quadratic regression. So then, Valeska, it was you that asked how to store it, right?
Yeah.
L1 is my X, L2 is my Y. I skip frequency list. I go to store EQ, and that's where I want to put Y1. So alpha, trace, Y1, go down, calculate.
Let's say you had an equation there. Would it replace it?
Yeah. And I get that my curve is Y equals, it's 0.911 x squared minus 6.218 x plus 15.2. And then if I want to graph it so I can see it take its shape, again, it's not perfect, but it is the overall shape. And if I want to predict what F7.5 is, what do I do?
You put it in.
I can plug it in. I can go to trace and do 7.5. Ah, wait, sorry. I can go to calc value, or not, 7.5 and hit enter. And it gives me 19.7937, so 19.794. Or I could go back to my home screen and I can do Y1 of 7.5. So there's a couple different ways to do it. You want to know at least one way of those?
Miss Chris,
Yeah.
how many of these questions are we going to have?
There's one big one like that. And then there's one where it tells you what it is and asks you to give the equation, which I think there's one.
A 2-question quiz.
Got it. All right. So I did not put inversely and directly proportional on your quiz, but obviously it's on your test. Should I open up the homework? I'll go back to the homework in a second. All right. Listen. Relate or proportional, guys, are hopefully things you've heard before, okay? If y is directly proportional to x, then the equation is y equals k times x, where k is a it's called a constant of proportionality. You are then going to find k. So it's going to say y is directly proportional to x. When y is this, x is that. You plug it in, you solve for k, and then you set up your actual function. If it's inversely proportional, then the equation is y equals k over x, where again, k is a constant of proportionality. So inversely, the x goes on the bottom. Directly, you multiply them out. Yeah, because it's got multiple parts. That's like, these will be word problems that say something like this. The force in newtons exerted by a magnet on a metal object is inversely proportional, and obviously that's important, to the square of the distance in centimeters. If a magnet exerts 60 newtons on a metal object 2 centimeters away, what will the distance be when the force is 10 newtons? So our two variables are force and distance. We can make that F and D. You could literally make it whatever variable you want. But the force is inversely proportional to the square of the distance. So the force is inversely, means whatever's after this is coming under K. The force is equal to K over the square of the distance, so D squared.
K is like a constant.
K will always be your constant. And we're going to solve for K first, and then we set up our equation. So it says if a magnet exerts 60 newtons, so that's my force, 60 equals, on a metal object 2 centimeters away, 2 is my distance. What will the distance be when the force is 10 newtons? I have to solve for K here. So 60 would equal K over 4. Multiply 4 on both sides. And K is 240. So my relationship is that the force would equal 240 over the distance squared. So this says, what will the distance be? I'm looking for D when the force is 10. So if 10 equals 240 over D squared, I can put 10 over 1. I can cross multiply these, or I can multiply by D squared. I get 10D squared equals 240. So D squared is 24. And the distance is the square root of 24. If kept exact, I would rewrite that as 2 root 6. If on a calculator portion, I would literally square root it. It's going to be like a 4.9-ish, right? Because that's close to the square root of 25. And this would be the distance, which means this is in centimeters. So 3 decimal places is actually 4.8989. So this bumps 4.899 centimeters.
Plus and minus or is that?
No, that's only, I mean, you can't get a negative distance. Yeah. So yes, if you're solving algebraically, you would do plus or minus, but we're talking about a real world scenario in which it wouldn't be negative. Questions? There's one in the home. All right. Last part goes back to piecewise. So it says the following model tracks the amount of accumulated rain water during a storm, where X is the time in hours and F is the accumulation of water in inches. Find F of 4, what does it mean in this context, and find the average rate of change from 3 to 5 hours. So now we're doing it without a graph, right? If I want to find F of 4, what do I do? Good. Figure out which one it goes into. 4 would be greater than or equal to 4, less than or equal to 6. So I pick the bottom one and plug it in. That would be 4 plus 4, which is 8. What does that mean in this context? Good. After 4 hours, 8 inches of rain has accumulated. B, enjoy the last day in those seats, people. B says find the average rate of change from 3 to 5. So I have to find F of 5 minus F of 3 over over 5 minus 3. F of 5 would be plugged into which equation? That bottom one again. So it would be 5 plus 4, which is 9. F of 3 would get plugged into which equation? The middle one, which is just 6. Over 5 minus 3, which is 2. And I'd get 3 over 2, or 1.5. So the rate of change of inches of rain per hour. That says 1.5. I know it's hard to read. Questions?